Okay, so today I'm going to talk about bad bots and how they evolved lately and what you can do about it to secure your website. So I'm Antoine Vastel. I'm the VP of Research at DataDome, a cybersecurity company helping website and mobile application to get secured against bad bot attacks. So what's the state of bad bot detection in 2024? So if you are familiar with bad bot, if you made a bot maybe to scrape some content or, these kind of things, maybe you were familiar with puppeteer stealth. So this is a framework that was used by attacker to create an automated Chrome, Headless Chrome, based on puppeteer, but with a modified fingerprint to avoid being detected. So this is a highly popular library, or this was a highly popular library, because it made it easier for attackers to avoid being detected too easily because of inconsistent fingerprints. The library was modifying several information about the GPU, about the time zone, etc. to appear more human. The problem is that lately, this library has become really counterproductive and it's not needed anymore because it introduced a lot of side effects that makes it easier actually to detect people making bots with this library, which is not the purpose. And why? Because last year, around May or June, Google released a new version of Headless Chrome. So Headless Chrome is the go-to technology, go-to solution for attackers to make bots. Because you can basically leverage Google Chrome, but without having to render anything. So it enables you to make bots that have all the features available in a browser, but that use less resources, less CPU, less RAM. And last year, Google released a new version of Headless Chrome that is located on the same branch as the real Chrome. So it means that the fingerprint of the bots that use this new version are almost perfect. It looks like the fingerprint of a real human browsing the web with a Chrome browser. So any attacker now can use it and has a near perfect fingerprint. Cool for them, not for the websites that want to protect against this kind of bots. So what are attackers doing now? Because they have Headless Chrome with a near perfect fingerprint, they create new generation of frameworks. So before they were using puppeteer extra stealth. Now, for example, they are using things like Selenium driverless. This new generation of frameworks, they try to erase lower level side effects like CDP detection. So CDP is the Chrome DevTool protocol, which is basically the technology used to instrument Chromium-based bots. And there are still some side effects when you use Headless Chrome, but attackers are creating new open source frameworks that makes it easy for attackers to instrument Headless Chromes without having this kind of detectable side effects. But it's not only about headless browsers. Even if you want to make a bot that does not execute JavaScript, let's say a bot that uses Python script, Go, or Node.js HTTP clients, attackers can use different libraries that make it really easy for them to spoof low-level signals like TLS fingerprints. So on this screen, I show you Noble TLS, which is a library, which is an HTTP client basically, that enables an attacker to have a perfect TLS fingerprint based on the user agent. So you use a Python script, you want to make thousands of requests, but you don't want to be detected. And maybe you will get detected because you have a WAF that will detect an inconsistent TLS fingerprint. This library, you just need to provide a user agent. So for example, the latest Chrome user agent on Windows, and it will automatically take care of forging the real HTTP headers linked to this version and the proper TLS fingerprint. This way, if you have a CDN, if you have a WAF, it will look like your request is coming from a real Chrome on Windows. It's not only about TLS fingerprint, browser fingerprints. You also see the same phenomena with mouse movements, for example, behavioral signals. Attackers have access to a wide range of libraries that make it easy to forge more realistic human mouse movements. I'm not saying this is exactly how a human user would move a mouse, but it's less obvious than moving the mouse in straight line. So if you use simple detection signals like detecting, sudden jump of mouse movements, these bots can go through by generating more realistic mouse move that looks like a Bezier curve instead of a straight line. And if you look at the screen, all the things that I showed, all the other frameworks, they are compatible with Puppeteer, with Selenium. So all the attackers that develop, these tools to lie about the fingerprint, lie about the mouse movements, they make their frameworks compatible with all the existing tooling, with Puppeteer, with Playwright, with Headless Chrome. This way, the attackers, they can easily import these libraries and use them with their existing bots. They don't need to change everything because the API is compatible. On top of that, attackers have access to millions of IP addresses. So they can rent millions of IP addresses using residential proxy services. These are proxy services like Bright Data, formerly known as Luminati, Smart Proxies, Oxylab. They enable people that are making bots to route requests of their bots through devices that are part of their residential proxy networks. So it means that as an attacker, you can use proxies that are located, for example, in Singapore, if you want to attack a website located in Singapore. You can use a French IP if you want to target a French website. This way, from the website point of view, it looks like the bot requests are coming from thousands or hundreds of thousands of IP addresses. So it enables attackers to bypass techniques like rate limiting per IP address. And also, from the website point of view, the request comes from a well-known ISP. It comes from CAPTCHA, from AT&T. So it's not suspicious at all because this is the same kind of ISPs that your human users are using. So you can't just block a whole IP because it belongs to a data center. No, it comes from a legit ISP. So you can't do it. Depending on what you're trying to do, for example, if you're trying to do scraping attacks to get access to content online, you may use bot as a service. So a bot as a service is a service that is accessible through an API, and this service takes care of making the bot request on your behalf. So as an attacker, you just provide the URL that you want to access, and then the bot as a service will forge the HTTP headers, forge the TS fingerprint, try to pass the CAPTCHA using a CAPTCHA farm, rotate the IP using a proxy network. And as a bot developer, you don't need to do anything. These services, they take care of all the difficult work on your behalf, and you just need to pay for successful requests. So it's really convenient for attackers because they only pay if it's successful. And if you look on the screen, you see a lot of services like Bright Data, Smart Proxy, Oxylabs. These used to be proxy networks. All these proxy networks, they also started their bot as a service to make it really easy for attackers, for people that are not familiar with advanced bot development, to make sophisticated bots. So this means that even today, even people that are not expert in bot development can leverage, all the things that I presented before, clean fingerprint, etc., because you have services that monetize it. And when we talk about bot detection, we need to talk about CAPTCHA. You are all familiar with CAPTCHA, probably, when a website asks you to select, traffic lights or fire hydrants to prove that you're human. And I'm pretty sure all of you hate these kind of things because it's really painful. It may take a lot of time. And what a lot of researchers have shown lately is that on top of being annoying for real human users, they are completely useless. Why? So these researchers studied different traditional CAPTCHA. So what I mean by traditional CAPTCHA, these are CAPTCHA that rely on the difficulty of the challenge to make it secure. Because the way CAPTCHA used to work was by having difficult challenges. Challenges that were supposed to be solvable only by human users. And in the past, these was things like tasks that involved image recognition or audio recognition. But today, I mean, if you go like in any booth, they will talk about AI. And there was a lot of progress around AI, particularly in terms of image recognition and audio recognition, which means that today, you can use a lot of free APIs or paid cloud APIs to automatically solve image recognition techniques. For example, ask to locate, the chimneys or to rotate an image. So these kind of challenges can be easily solved by an attacker because the security of the CAPTCHA is in the difficulty of the challenge. And these researchers from several universities, they studied the top, CAPTCHA providers like reCAPTCHA, Arcos, Gtest, and they showed that with a bot, they were able to solve most of the CAPTCHA faster than a human user. So it means that this CAPTCHA, on top of being annoying, in addition of being annoying for human users, so your users that are trying to spend their money on your website, it's not secure, it's not preventing bots from accessing your website. And particularly because what we observed lately at DataDome is that CAPTCHA farms started to leverage AI-based image recognition techniques or audio recognition techniques. In the past, if you were using a service like CAPTCHA, they were sending the CAPTCHA to a human worker, mostly in South America or South Asia, to ask them to solve the CAPTCHA on the behalf of your bot. And it took between 40 to 45 seconds. It was quite slow. It was not that much of a problem because you could parallelize it, but it was slow and it was costly. Let's say $3 per 1,000 reCAPTCHA. Today, because these services like CapSolver use image recognition techniques, they use machine learning, they were able to divide the solving time by 9 and to divide the price by 3. So it means that forging or passing CAPTCHA with a bot has become way more affordable, and attackers are leveraging it. So how does it benefit attackers? Because I showed a lot of tools, and most of these tools are open source or can be used through paid APIs, but it's not that expensive. So to illustrate my point, I will talk about OpenBullet 2. OpenBullet 2 is a tool that can be used to conduct credential stuffing attacks. So attackers can use it to steal user accounts. So this is an open source tool. You can use it in different modes, basically. It offers possibility to run a real automated browser, so based on Headless Chrome, but you can also run a browser that doesn't execute JavaScript and that just makes HTTP requests. If you just make HTTP requests without executing JS, you can make way more requests because it costs less. It's a trade-off between being detected and scaling your attack, basically. They have different integration. It's a really convenient tool for attacker. You can make an attack for free without knowing how to code. So for example, you can do drag and drop to add a CAPTCHA solving service in your flow, in your attack flow. So basically your attack is blocked. Okay, fine, because there is a CAPTCHA. You can just use one of the blocks that they provide to solve HCAPTCHA, Gtest, or reCAPTCHA. Most of the time, you just need to provide an API key linked to a CAPTCHA farm like CAPTCHA or CapSolver, and then your bot will automatically be able to pass the CAPTCHA and continue its attack. And it's really easy for attackers because you have a lot of free configuration to target the most popular websites. So this is a screenshot I took on the forum, but you can find a lot of free configuration on GitHub as well. And for example, you have configuration for NordVPN here, or for Disney+. So basically, whenever a website has a login endpoint, it can be a mobile app, it can be a website, you will have a configuration on a forum or on a GitHub that can target this endpoint automatically. You don't need to know how to code, you don't need to know how to move the mouse realistically, etc. You don't need to know how to start Headless Chrome, to use proxies, because everything is drag and drop, and when you don't know how to do it, you can just, use a script that you found online, a configuration script. And what we see as well is that they even take care of, some CDNs that add some mitigation techniques. For example, here, on the last line, we see that they try to bypass simple WAF like Akamai, for example. Okay, so it's quite pessimistic. I'm like, okay, bots have a real fingerprint. They move their mouse in a realistic way. They have access to millions of residential IPs. They have CAPTCHA solving services. what can I do to secure my, my login endpoint, my website, my mobile app? I'm not going to lie, this is not that easy because attackers are adapting. So, in summary, attackers have perfect fingerprints, particularly JavaScript fingerprints, because Headless Chrome made it easy, for example, but in general, you have a lot of open source frameworks that makes it easy to lie about your fingerprint. Browser fingerprint, TLS fingerprint, all of these things can be easily spoofed today using open source tools. Bots can also easily solve traditional CAPTCHA using CAPTCHA farms, because this CAPTCHA farm, they scaled using AI image recognition or audio recognition techniques. All of these improvements are integrated into specific tools like OpenBullet 2, for example, to conduct credential stuffing attacks. But it's not only about credential stuffing attacks. You have the equivalent for DDoS attacks. You have the equivalent to test stolen credit cards. You know, each type of attackers, they develop, you know, their tooling for specific type of attacks. And every time there is an improvement like this, you know, they will be able to better lie about their fingerprints. So because of this, it's really important to have a detection that uses a multi-layered approach, because you can't expect to catch attackers only using fingerprint or only using behavior. You need to use all the signals available to ensure that, you know, you have all the chance on your side. You want to analyze the user behavior at each request, keep track of the user session, the IP activity, use proxy detection, advanced browser fingerprinting. Traditional detection techniques are not enough. You really need to keep that in mind. You know, if you have a WAF doing simple IP rate limiting, CAPTCHA, I'm not going to say this is useless. It may stop some of the most simple bots, but today you have open source tools, so you don't need to pay anything. And with these tools, you will be able to bypass signature-based detection. You will be able to bypass CAPTCHA. You will be able to bypass rate limiting. So depending on your use case, you may be able to integrate some countermeasures on your website or mobile app. For example, for credential stuffing, I strongly encourage you to use multi-factor authentication. It makes the life of attacker way more difficult, because even if the credentials leaked and the attacker is able to find the password, you will still have to find, you know, the second factor. In case of fake account creation, you may want to detect disposable emails. You may want to enforce phone verification. But there is no silver bullet, because even if you use phone verification, it may cost you a lot in terms of SMS if bots are making a lot of requests. So to detect sophisticated bots, you need a sophisticated bot detection tool like DataDome that use real-time bot protection using different kinds of signals from fingerprinting, real-time behavioral analysis, proxy detection, in particular to be able to quickly detect distributed attacks where attackers use millions of residential IPs. The bot protection tool should be resilient against CAPTCHA farms, because today most of the attackers will try to pass the CAPTCHA if you show one to them. So you need to have a resilient CAPTCHA or a bot detection tool that can, you know, detect that a CAPTCHA has been passed by a CAPTCHA farm, all while safeguarding user experience. Because here I was talking about detection, and I was saying that CAPTCHAs are really painful. We all hate, you know, when you are trying to buy something and we are stopped and asked, you know, to pass a lot of CAPTCHA. When it comes to bot detection, what we do is we analyze a lot of signals in real time in the background. It means that most users won't even notice that we are analyzing something. We will only challenge requests that comes from malicious traffic. All the other human users won't notice anything, and for them it will be a completely normal user experience, contrary to what they would get with a traditional CAPTCHA. Thanks a lot. I think we still have time for a few questions. Otherwise, I will stand behind the booth. Any question? Yeah. Okay, so he's asking why, you know, Headless Chrome has such a clean fingerprint, and why is Google helping the bad guys? That's it? Okay. Yeah, that's a good question. A lot of people ask this question, you know, online, and whenever I present it. The main reason is that, so Google is not crazy, you know, they are not trying to help attackers, but Headless Chrome is used a lot for testing purposes. You want to test your website. And actually, when Google released the first version of Headless Chrome, it was really cool for web developers because it made it really easy for them to test, you know, in a CI/CD what their end users would get. And so it made the life of everyone easier. But at the same time, it made the life of attackers easier as well. And with the latest version, it's worse. But the reason they did the improvement on the last version is that because a lot of people were complaining that some features like, you know, Chrome extensions, like some features were not available in Headless Chrome, and they really wanted to have one code base to make it, you know, the same as Chrome. But it also benefits attacker. Any other question? So you're asking if we need to install a SDK for mobile application. So yes, for mobile application, we'll install a SDK that we use to collect client-side signals like touch events, as well as fingerprinting information related to the device, like camera model, screen resolution, etc. And we also always have a server-side integration because client-side is, can always be forged by the attacker. So we also collect signals on the server side that is used to, enforce the response. So when we want to block or challenge a request, it will be enforced by the server-side module, but we have a client-side module as well. Yes. Any other question? Yeah. So how bad is the bot problem? I would say it depends on the customers. Like in some industries, in particular, website or mobile applications selling sneakers, I would say 95% of the traffic is bot. Like, you can't do outlier detection because the outlier is the human user on certain websites. And on others, on average, you don't have a lot of bots, and sometimes you have huge spikes of traffic linked to credential stuffing attacks, linked to DDoS attacks. So I would say it really depends on the industry. On average, 30 to 40%, but with extreme outlier depending on the industry. Okay, so you're asking if, as a website owner, you can understand our decision in terms of detection. Yes, so in our dashboard, when we take a decision, we'll provide information regarding what the attacker tried to do. So for example, was he trying to target your login endpoint or get information about a product page, etc. So the intent. And then we also provide information about how the attacker was detected and why we think this is malicious. So was it detected because of inconsistent fingerprinting signals? Like, let's say we detect a signature linked to Puppeteer Extra Stealth. We'll say, okay, we know the signature, we think this is Puppeteer Extra Stealth. Or we think we detected it because of malicious mouse movements, etc. So we try to convey as many context as possible, but this is not always possible because we aim to block from the first request before as soon as possible before the request can make any damage to the infrastructure. So sometimes you block because you detect, inconsistent TLS fingerprint. And so at that stage, you don't know, maybe the bot could have executed JavaScript, maybe the bot wanted to do a carding attack. So you don't always have the full context depending on how early you block. Okay, it's time to stop, but if you have any other question, we can discuss privately close to here. Thanks a lot.